Welcome to CloudEdge IT Academy. Today, we're celebrating Republic Day and recognizing some of the top Indian ethical hackers. This video is a complete course on society detection engineering, focusing on the core comparison between Kusto Query Language, or KQL, and Search Processing Language, or SPL. Our agenda covers KQL versus SPL, society use cases, MITRE ATT&CK mapping, and the roadmap to becoming a detection engineer. Our goal is to move from a copy-paste analyst to a logic-based engineer. KQL, or Kusto Query Language, was originally built for Azure telemetry. It's optimized for massive, structured data sets within the Microsoft ecosystem, used in Microsoft Sentinel and Log Analytics, and is read-only, which makes it safe for junior analysts. The KQL philosophy emphasizes filter first for performance. The steps are to filter to reduce the dataset, transform to project-specific columns, and then analyze the refined data findings. SPL, Search Processing Language, is inspired by Unix piping. It's the powerhouse behind Splunk's versatile data ingestion, used in Splunk SIEM and Splunk Cloud. It can ingest any text data and is extremely flexible for on-the-fly field extraction. The SPL philosophy allows for schema on read, offering ultimate flexibility. The process is to start with a broad search, extract specific fields using regex, and then refine the results until the insight is clear. At a high level, KQL is structured like SQL, offering high speed. SPL is flexible, like a Google search that becomes a table later. KQL is built for massive scale, while SPL is built for deep forensics and messy logs. The schema battle highlights key differences. KQL has an enforced schema, requiring data types to be defined upon ingestion, which ensures consistency. SPL uses schema on read, storing raw logs as is, and defining fields during the query, offering infinite adaptability. Let's examine a case study, failed login. The logic is that one failed login is noise, but 105 minutes is a signal of an attack. The goal is to detect high-velocity event ID 4625 for Windows or authentication failure for Linux, coming from a single source IP targeting one user. The KQL strategy emphasizes scoping the time first to optimize the query. Summarizing by both account and IP helps identify both distributed attacks and single target attempts. For the SPL strategy, specifying the index, such as index equals security, is crucial. Avoid searching index equals asterisk in production, as it severely impacts performance by scanning every bucket. MITRE ATT&CK 1110 covers brute force techniques like password spraying and credential stuffing. A detection tip for spraying is to count distinct users per source IP. Impossible travel detection uses the speed calculation between two IP locations. A common threshold is speed greater than 500 miles per hour. Be aware of false positives from VPNs and cloud proxies, which can make users appear in multiple places simultaneously. Living off-the-land attacks aim to blend in using built-in tools like PowerShell. The hunt involves looking for rare command lines or encoded base 64 strings. This signal often is PowerShell downloading files from unusual external domains. Data exfiltration detection focuses on abnormal outbound traffic. This includes connections during non-business hours, mass file transfers to personal storage, and high-volume DNS queries indicative of DNS tunneling. Our tuning strategy recognizes that context is key. While clearing logs is malicious for a standard user, it's normal for a backup script. Also, remember the tuning tax. Allow a burn-in period to list legitimate behaviors before turning rules into critical alerts. The detection engineering roadmap starts with Phase 1, Foundations, Mastering Logs, and Query Syntax. Phase 2 is Threat Hunting, which is hypothesis-driven. Phase 3 is Engineering, where you build behavior-based automated alerts. For interviews, adopt the modern detection engineer mindset. Focus on high-fidelity detections. Prefer 5 actionable alerts over 100 alerts that are ignored. Choosing your SIEM depends on your environment. Microsoft shops primarily use KQL. Hybrid environments with messy logs lean towards SPL. If you need advanced analytics, you may use both. Integrating generative AI, or GenAI, into SIEM systems modernizes society operations. In threat intelligence, GenAI automates data analysis, provides real-time threat detection, and improves phishing detection. For incident response automation, GenAI can create and execute automated playbooks, drive investigations by correlating events, and accelerate ticket resolution by prioritizing and assigning incidents. GenAI enhances SIEM systems through anomaly detection, correlating disparate security events using deep learning, and creating self-tuning models that continuously improve detection without manual updates. Utilizing natural language processing, or NLP, for threat intelligence allows GenAI to generate natural language reports for incident reviews and handle intelligent queries from analysts regarding security posture or incident status. GenAI also assists with training and skill augmentation by simulating attack scenarios. For collaboration and knowledge sharing, AI-driven knowledge bases assist in sharing insights and integrating security improvements across departments. Other benefits of GenAI include a drastic reduction in alert fatigue, natural language interaction with the SIEM, automated investigation, accelerated onboarding of log sources, and contextual insight across different security tools. Core use cases for GenAI with SIEM include threat intelligence summarization, detection rule generation and conversion, adversarial simulation for control validation, and automated report generation for compliance. A key challenge with GenAI is data privacy and security. Many solutions use retrieval augmented generation, or RAD, to provide context while ensuring sensitive data remains secure. The key benefits of GenAI in SIEM are faster response times, improved detection accuracy, cost efficiency through automation, and continuous 24/7 monitoring capabilities. For a golden interview answer, tell potential employers that you map queries to the pyramid of pain and focus on MITRE-mapped behavior-based detections. Remember, practice and labs equal success. Stay informed and prepared. Subscribe to our channel for the latest updates on cybersecurity trends and tips. Together, we can build a safer environment. Thank you for watching the CloudEdge IT Academy video.